University of Exeter. Have you got the right leads, Alison?
I'm hoping so.
So Alison joined Jim's group from the ANU in 1991. There we are. It's very young Alison there. In a punt, by the looks of it, and left in 1994.
How do we get Finian? Sorry. How do we get? Brilliant. No.
Is that it? We need to maybe.
Press left screen.
Yeah.
And then press the USB.
Oh yes, brilliant. Thank you.
The title's there, and I'll leave you with Alison.
Thanks. As I'll work out how to use the tech. Hi everyone. It's amazing to be here and to see so many people. I'm going to be talking about something a bit different. I'm a teaching specialist at the University of Exeter. I'm in a biological sciences department, but we have a biological and medicinal chemistry degree program, and I also teach on the biochemistry degree program. And so you can see there is a picture of me when I was a PhD student here, taken by Howard Cooper on one of our infamous punt trips. It was a great time. So I started in January 1991. And so I'd been backpacking for 8 months. So I arrived 3 months after Mark Loughran, Sandeep, and Rich Lloyd. So we're all in the same year. And I was assigned to work on the same bench as Adam Jacobs, who's in the front here. Now, because it was the 4th of January when I started, Adam, as the senior member of our Lab 220, decided that we would turn over a new leaf, and we had a small whiteboard in the lab, and he decided that he would use this to improve our vocabulary and put up this big complicated word on the first day. And as you can imagine, this quickly degenerated by the end of the first week. And so then they decided perhaps it would be a good way for me to teach them a bit about Australia. So they all knew what a kangaroo and a koala was, so that's a good start. So the first animal that I put up as a word, which none of them knew what it was a wombat. And from then on, for the next 3 years, I answered to the name Wombat in the Department of Chemistry at the University of Cambridge. So to share some details for everyone who's not in on the joke, this is a wombat. I like to think of them as cute and furry, but they have 2 very funny things that you should know about. One, and it literally is called the bum defense mechanism, is that when under attack, they will run into their burrow head first, leaving their bum out. The predator will try and bite their bum, which is actually like a rock. It's really hard. And then they push their bum up and crush them against the top of their burrow. I don't know what this says about me, but whatever. Keep moving on. The other thing is that they do cubic poos, and then they stack them to impress other wombats. What can I say? So it's the only animal that has cubic poo. And so if you do like wombats like I do, and you have a young member of your family, I can strongly recommend this rather wonderful book called The Diary of a Wombat. Right, now onto something that may or may not be of interest to you. So I'm a teaching specialist. I still get a whole course on polyketides, which I totally love every year. But I'm going to teach you about some of the teaching innovations that led to my award from the Royal Society of a Teaching Excellence Award. And Chris is in the audience here, and she nominated me. So big shout out to Chris for doing that. So it started when the fees went up by that extra £250, and all the second and third years at the University of Exeter who thought they wouldn't have to pay the extra 250 quid were very cross about this. So the university put all that extra 250 quid into one pot and promised the students that that money would be used to better their education. And they founded the Exeter Education Incubator, and I was one of 10 people at the university who was given a grant. And my grant was to help my students with their mathematical skills. So it turns out that in biosciences departments across the UK, the only one that insists on mathematics and chemistry is the University of Cambridge. Everyone else doesn't, including the University of Oxford and Imperial. So for my students on biochemistry, depending on the year, you're looking at 2/3, maybe 70% have done post-16 maths qualification. And because they get me in the second and third year, and I insist on doing some data analysis with maths, and they absolutely hate it. So in my second year course, which is all on biochemistry, analytical techniques, I had a problem. We had to do what I call the liver milkshake experiment, where I literally take a liver, put it in a smoothie maker with buffer, and then we use differential centrifugation to separate out into the cellular fractions, cytosol, the mitochondria, and the nuclear fractions. And then we assay for enzymes, and then they have to tell me where the enzyme is located and actually do some calculations on it. And so some students are fine with it, some students absolutely hate it. And I noticed that you could actually predict the performance on this module and another one where it required mathematics based on whether they had post-16 maths qualifications, which didn't seem fair to me since my university didn't require it. So I worked with a company called LearnSci, and we developed what's known as a smart worksheet. And typically, these are used for large first-year classes so academics don't have to mark 400 lab reports. But I used it to improve their confidence and their competence in the data processing. So we do all the lab, they work in teams of 4, then I put them in the computer lab and we spend 2 hours going through the calculations with each student individually doing their calculations. The actual platform that integrates nicely into the online classroom, it comes up, they have to enter all their data, it will plot their data, so this is a Bradford here. And then we're using this formatively. So I had changed the curriculum so they had to do these calculations in the exam in a data section. So it's improving their confidence and competence. And we found that the average went from a really terrible 49 to 57 to 72% in the first year on this data section. So I was absolutely thrilled. Not so much, it was a bit high, we changed it a bit. But this was the start of what led me to start developing individualized or personalized exams and assessments. So we all know what happened a few years ago now. And the pandemic meant all the assessments moved online. And I knew that assessments like mine, which had unique answers, one answer, the whole class could share them and they'd all get 100%. So before we get to that, I want to introduce you to the fraud triangle, okay? So I love this because A, it's simple, and B, it's a triangle, so it's mathematics. But it talks about the sort of pressure points or the incentives or the reasons that anyone, not just a student, might behave dishonestly. So you need to be under pressure, and all of our students, whether at Exeter or Cambridge, are under financial pressure, the cost of attending university, the cost of living, and so on. And if everything is online and it's not being invigilated, they can rationalise to themselves, nobody will know. No one can see me. I will be able to get away with this. Okay? And if I don't cheat, I'm at a disadvantage, which is true. Okay? But then the bottom line is it's the opportunity. When you're in an invigilated hall, you're having someone look at you. People still try and cheat, but it's much, much harder. Now, if everyone's at home or sitting around the kitchen table of their group house and doing the exam together, they now have the opportunity. They have the opportunity to use Google. I didn't worry about that. I just thought that they would do that anyway. But they have opportunity to use WhatsApp, Facebook Messenger, Skype, Zoom, whatever, to do their exams together, although we did catch the kids who used the university Zoom. Then there are a whole lot of what they call helper sites became very profitable. I call them pay-for-cheating sites. And if you read the literature, you can actually see exam papers appearing in real time with their answers as the exam runs. So I did enjoy the American professor who wrote in a paper that he knew people were going to do this. So he got smarter for about a quarter to a third of his questions. He spread them out over 4 of these things, and he asked his own exam paper questions a week before. Then he came in as the expert and answered them. And then when his students, but incorrectly, and when his students used those incorrect answers, he could then have them for cheating. So what can I say? You have to be smarter. And then, of course, now we've got all these large language models. ChatGPT is just one of them, which are causing of interest to everybody. I used to worry about my students cheating. Now I worry they don't know anything at all, and they just put it into there. So Phil Newton, who's an expert on this, he actually, with Essex, went around and they found that 2/3 of UK university students cheated during the pandemic when everything was online. It was 2/3. And he said the most common reason they reported was simply because there was an opportunity to do so. No one was looking. So what did I do? I just didn't even give the benefit of doubt. I just knew it was just too much of the incentive to cheat was too much to get 100% or 40% of the exam paper. So I decided I was going to give every student their own data, and so they would have to calculate them themselves. But you have to make it fair. So I've seen in the literature, they have given harder ones to good students and easy ones to less capable students. But I didn't think that was fair. So we took a single equation, and then for each variable worked out the upper and lower limits, and then used a random number generator within that. And that's how we generated as many as you like. And we can generate 1 million if you really want to. I only needed 100. But you have that parity, that it's based on the same question, but it is individual. And it can actually lead to the results being different. So this is an example of an exam paper. And in blue, I have shown all the things that we can change and individualize. So we can include images. So now we rolled this out to the second semester module. And now we produce these, and they all have their own and have to interpret them. But the most important thing is that you generate your answers for the marker. So in the pandemic, I marked them by hand. We've now worked out a way to automatically mark them. But I went to a conference where someone was using personalized exam papers for a class of 400 and did not generate the answers. That's going to take a lot of time to mark that. So I start off in an Excel spreadsheet with the equation, adding variability, working out what is sensible to make sure that it's pre-screened, hand it over to my colleague. He used R to do the programming. You could use Python, you could use anything, but we used R because that's what he knew. And we have now done the automatic marking, but this time we can't show working, which did really upset the students. So we have to screen it so we have intermediate steps so we can see the steps as you go through those calculations. We need answers that are easily written into a script. So before we would ask them to draw the Bradford curve. Now we put the instructions to do that, and then we say, now find the equation. Now we want to know what the value of M is and what the value of C is, and that's how we've constructed it. We originally used an Excel spreadsheet, and I give all the units here, and then they had to answer their questions in there. But now we're using our new exam system. But you could have this wonderful idea, but you can't actually do it unless it fits with the university exam regulations, where the administrators allow you to do it. You have to teach the students how to do it. But once you've done it, it's great. And if you do the automatic marking, the results are almost instantaneous. So we know the answers, and we have the student answers. So we're going to divide them. And if they are correct, we should see a number 1. And that would get the full marks. As you can see someone's got their dilution factor wrong by a factor of 2. Someone's got their powers of 10 wrong by 6. So when we originally go through that first screen, we will give 0 for a wrong answer and 3 for a correct answer. Then we pick out the patterns and we can decide how we award the partial marks. What's really good for me is when they make a mistake in the first question, it will carry through. And as long as that ratio stays the same, we know what's going on. So I don't have to do hand calculations. So it's worked really well. So let's look at some data here. So we took a 1-hour invigilated closed book exam. We turned it into a 24-hour open book non-invigilated exam. For most in my department, we saw a massive grade inflation, about 10 marks, so 10%. So 2-1 moved to the first and so on. For us, that doesn't happen. So this is prior to the SMART worksheet. First blue line is the introduction of the SMART worksheet. You can see the improvement in marks. Made it a bit harder in the second year to make it so an average of about 68. That was better. Second line now is the pandemic. And you can see if we compare this with this, we see no data difference. The marks stayed exactly the same. We were the only module in the entire university without grade inflation. But you can see there's a big statistical difference to the prior to the smart worksheet. It's been a game changer. Same. So these two exams were 24 hours. Then the university decided, right, we're all back. We're going to have 3 hours now. So it's gone from 1 hour to 3 hours. And you can see the marks have now come down to where they were before, even though we've got a smart worksheet, and that continued. And we think it's the lack of preparation now. They're not used to preparing for the exams, and we're still working on that to get the marks back up. So that's a bit disappointing, but it's kind of cool that smart worksheets work and our methodology work. And then we decided to do what is known as red teaming. It's called red because China and Russia, both their colours are red, and it's what the Americans decided to test all of their computer systems. They would have other teams that were friendly try and hack in. Okay, so it's called red teaming. In this case, what we did, my colleagues and I, on fake student numbers, we cheated, and then we put our exam papers in with all the rest of the class, and we used a statistical process called k-means clustering to see if we could detect us, and you can see, yes, we can detect us here. And could we find anybody else? And the answer was no. So we have confidence that they're not cheating. I cannot give 100% guarantee, okay? But it is a good way to teach, or to test it. And we do tell our students, and if you read the literature, the mere fact of telling them that we don't like cheats and we're going to look for you and we will take you to the cleaners is normally enough to stop them from doing it in combination with these unique exam papers. So what are the advantages and disadvantages of our method? So it's really good, obviously, for academic honesty. My university is still using online exams because the students like it. Of course they do. But this automated marking and the red teaming has been a game changer, and it gives all of us confidence in the outcomes. But it takes longer to set the exam. We've finally got that in our workload model. And every year we seem to have to always explain to the exams office what we're trying to do. The automated marking, you need the clear answers, but it really has been good to have parity across the whole group, making sure that mistakes are rewarded or punished in exactly the same way. So what do the students think? Because they're part of this equation. And now 2 biochemistry modules in the second year, the only ones that operate like this. So for the smart worksheet, they really like how it breaks down the calculations into steps and helps them through. So there's a magic solve button as well if they really get stuck. But that allows them to get rid of their mathematics anxiety, basically. As for the personalised exams, they absolutely love it. So you can see they're no longer worried about everyone else cheating. They just sit there, get on with their work, because they don't have to worry about people working together. And they say, look, why would we help someone when we've got a different question? And the type 4 is this 3-hour exam. So now they're in time pressure, they're not going to bother about it. They all just get on with their work. So this led to my colleague, Steve Porter, joining our team, and we won a teaching award from LearnSci for this. So this is for a first-year biochemistry class, when they realised that the class data set was being used a lot more than it should be, and people could work in teams and all get 100%. So we created a PDF which has some smart JavaScript in it, and you put in your student number, and then some prime numbers are used, and then the remainder is used to give that variability in the class data set. And so this has been used for classes of 400 students. Everyone has a different data set. And unlike us, when we press the button, if we repress it, it's all completely new. This one here, it's always the same data for that student number. And we've got a watermark in there to make sure they're actually using their own student number and not somebody else's. Again, we don't trust them that much. So this technology has been put out through our whole department for chemistry and biochemistry and biology, and it's now moving out into the medical school. And this leads to me talking about this gamification session that my colleague Nick and I have corrupted my colleagues to really do this innovative education. And we went a bit rogue, I suppose. So we created these sprites. I like this one here. This is Dalmatian sprite in a demonstrator coat. And basically we told our students, and our head of department was on board, that we have a murder in the building. And these lab sprites live in our basement, and they come out at night and they rerun experiments and fix everybody's data for them. But one day they wake up and one of the sprites has been murdered with a P1000 tip through their heart. And the job of the students is to solve who is the murderer and find out who it is. So it's a murder mystery based on a game called Among Us that Nick and my children played during the pandemic, which has been popularised by the TV series called Traitors. Okay, so I don't have the right fringe, but you got the right idea. We're using this in an biochemical analytical chemistry module right at the end, where all the people who've taught the different modules come together and we're getting them to use all the data points. Because we found that students in their lab work were relying only on one piece of data and not worrying about the contradictions from other techniques. So we're using HPLC, SDS page, mass spectrometry, and Western blots. We can make the game small or large depending on how many characters we put in and how many missions we do. And we have a more straightforward version for forensic students and a more complicated version for our own students. So the sort of data we have for the mass spec, we made up our own blood type for the sprites. So we have 6 blood types, which we then use the Western blot to work out which one it is. And then my colleague Nick had to create, using R programming, an HPLC generator as well as an SDS page generator. And with the HPLC, we will change the percentage of acetonitrile, and the numbers will move and all this. It's really, really clever. And we were greatly honoured to win another Teaching Innovation Award for this earlier this year. So in conclusion, because I'm almost out of time, I would just like to say, sadly, that academic misconduct is normalised, not just in Exeter, but across the UK and across the whole sector. And students are really confused about what's okay, like when to work together and when not to work together. But basically, any assessment like mine, which has unique answers, is going to be at risk of collaboration, working together, cheating, whatever you like to call it. Our approach of using these unique data sets keeps our assessments robust. I've only had a chance to tell you about one. We've done it in all sorts of things. And our students have confidence in this approach. We have spoken to them. But you really need to have that marker version. That is essential. But the automated marking and the red teaming allows the scalability of this. So we had only 60 students in the pandemic. We've gone up to 120. We can use this technology for the large first-year classes as well. And just to say, gamification is terrific fun. The students like it. We've actually developed a serious game for our second semester as well. And I really would recommend that as a way for getting student engagement. But please, can we all go out there and educate or re-educate our students when they can and cannot work together? Because it's really a bit too late when they've been hauled in front of the academic misconduct office. So a few thank yous. I really want to thank Jim. My career went a bit pear-shaped. I have this unique ability to pick departments of chemistry that closed. I did that twice. But I have managed to regroup and forge a career at the University of Exeter. I'm very fortunate to work with these brilliant colleagues, Nick Harmer and Steve Porter. This is part of the red team. We also got the GTAs helping in there. I've got QR codes if you want to go to our papers. And I just want to say to everyone who's come, we all know how much Jim meant to us and how, even though, as I said, I had 10 years as a PI doing biosynthesis, which was really fun, he was always really interested to hear about my teaching as well and about the innovations that we were doing at the University of Exeter. And finally, I'd like to thank you for your attention.
Thanks, Alison. That was brilliant. And also, something maybe for those of us in the universities, we should find out a little bit more about it. I also know Jim was so proud when you got the prizes. And he was super interested in education, as we've mentioned. So,